Okay, so let's look at to this question 12. Okay, so this is electrolytic cell. Okay, and then the information that we have in the question, we have a 2 platinum electrode. Okay, means that we are using inert electrode that does not involve in the reactions. Okay, and then we are using a copper sulfate aqueous solution as an electrolyte at the temperature of 25 degrees C. Okay, and then now the information that we have that is given here is the copper metal is deposited to one of the electrode. Okay, and then the oxygen is produced at the other electrode. Okay, so the equation is given here. Okay, it just said that it is deposited to one of the electrode, right? But it is already here, okay, with the arrow. Okay, when we have a cathode here, then the reaction that is happening here is the copper 2 plus react with the 2 electron turns to copper solid. If let's say the question give no information of this, then you should be able to know that this is actually happen at the cathode. Okay, and then for the anode, it said that oxygen is produced. Okay, so you should be able to write the equation, the oxidation equation that is happen at the anode. Okay, which is when we have a H2O that is oxidized. Okay, with the equation of the 2H2O liquid. Okay, react with, it turns to oxygen gas. Okay, with 4H plus aqueous with 4 electron. Okay, this is the equations of a reaction that is happen at the anode. Okay, I just rewrite back what is happen at the cathode is Cu2 plus aqueous. Okay, react with the 2 electron, then it turns to Cu solid. The first question, it asks us what is the direction of the electron flow. Okay, so the electron is always flowing from the anode to cathode. Okay, so we write, okay, the direction is from anode to cathode. Okay, but the question actually asks us to show the direction, so we have to show it here. Okay, the answer is actually given here. Okay, then for the B, write the balance equation. Okay, so this is the purpose of having the 2/2 equation, because we want to write the overall equation of a reaction. Okay, so to have an overall equation of a reaction, we need to cut the electron. Okay, we don't want the electron to come out in the overall equation. So to cut the electron, we have to make sure that the number of electrons are balanced. Okay, so if you look at to this 2/2 equation, oxidation equation are having 4 electron released. Okay, and it should be 4 electron that is also received by the cathode. Okay, so we multiply this reduction equation, okay, with 2, so that we will have 4 electron here. So if it is 4 electron, means that it will be 2 copper 2 plus 4 electron and 2 Cu solid after we multiply it with 2. Okay, and then now we can have the overall equation of a reaction. Okay, we cut electron with the electron. So we will have a 2H2O liquid, 2 copper sulfate aqueous, produced 1 oxygen, 4H plus and 2 copper solid. So we write the answer in the column that is given. It will be 2H2O liquid plus with 2 copper, 2 plus aqueous. Make sure that you have a state for all. Okay, and then it will turns to oxygen gas plus 4H plus aqueous plus 2 Cu solid. So that is our overall equation. Okay, now question C. Okay, the electric current, okay, the current is 1.5 ampere. Okay, pass through the cell for 40 minutes. Okay, so we have a I and also T. Then the question asks us to calculate the mass of the copper that is deposited at the cathode. Okay, through this equation. So this is actually the reverse process of what we have done just now from the previous example. So we start by calculating the Q. Okay, the charge that is flowing is equal to IT. Okay, so the Q is equal to, the I is 1.5 ampere, multiply with the time, which is 40 minutes, multiply with the 60 second.
3,600.
Column. Okay,
Yes.
so now we already have the charge. We can calculate the mass of the copper. Okay, so use dimensional analysis is the simplest one. So we put gram of the Cu as the subject. Start with the column 3600 charge that is flowing. And then we multiply it to get the number of mole of electron, because we know that for every 1 mole of electron, it is 96,500 column of the charge. And then from the equation here, okay, this is the step to calculate the number of mole, and then the next step to calculate the number of mole of the copper deposited. So for every 2 mole of electron that is flowing, okay, according to the equation, 2 electron, 1 copper. So 2 mole electron, 1 mole of the Cu solid that is produced. And then we want mass of Cu. So for every 1 mole of Cu, 63.55 gram of Cu that will be produced. Okay, 1.18 gram of Cu that will be deposited at the cathode. Okay, that is for the products that is produced here. Okay, the previous question, previous example, we just determine the current, okay, from one side, okay, from the product at the cathode. So this time in this question, okay, the question asks us to determine about the product that is at the cathode and also the product at anode. So we know that at anode, okay, it produced oxygen gas through oxidation reaction here. Okay, so now the question wants us to calculate the volume of the oxygen. This is what I said just now. Okay, but if you want to know the volume occupied by the bubbles of oxygen, you can see the bubbles here, right? Okay, the volume occupied by the oxygen, okay, we have to know what is the amount of oxygen or the number of mole of the oxygen that is formed first. Okay, and you have to know that the current that is flowing, okay, the charge that is flowing in our cell, okay, will be the same either at the cathode or anode. Okay, so if at the cathode just now we are using 3,600 column of charge that is flowing, that is the same charge that is flowing at anode. Okay, so we start with the charge that is flowing by calculating the number of mole of the oxygen that is produced. Okay, because we cannot strictly calculate the volume, because volume need to apply PV equal to nRT. Okay, so we calculate the number of mole of the oxygen first. So by applying this charge, okay, now we want to know mole of oxygen gas that is produced. Okay, start with the charge, which is 3,600. Column of the charge, okay, is, now we want to see the number of mole of the electron. Okay, for every 1 mole of the oxygen that is produced, 4 mole of electron that is transferred. 1 mole of oxygen, 4 mole of electron. We write here 1 mole of electron is 96,500 column of the charge, and then for every 1 mole of O2, it is 4 mole of electron that is transferred. Okay, so we press the calculator so that we will get the mole of the oxygen.
9.326 exponent -3.
Okay, so we have the number of mole of oxygen. We can calculate the volume occupied by this oxygen is by applying PV equal to nRT. So V is equal to nRT over P. So N is 9.35 times 10 negative 3. R is 0.0821. Multiply with the temperature is 298.15 Kelvin. We convert it from 25 degrees C to Kelvin. Don't forget, it cannot be in degrees C. It has to be in Kelvin in calculation. Okay, divide with the pressure that is given is 1.16 atm. Okay, so finally we will get the volume occupied, okay, by this oxygen gas is equal to 0.197 liter. Okay, so with this, okay, we have completed the electrochemistry topic, in which electrochem divided to two, right? We have a Voltaic and also electrolytic cell. Okay, so electrolytic, we have two parts as well. We have qualitative and quantitative. So we have complete both part.